everybody. So in this video we're going to talk about how to graph quadratic equations using the X-intercepts. Okay, so last time we talked about graphing using the vertex form where you plotted the vertex and then plotted the other two key points. And here we're going to talk about using X-intercepts. So first let's say a reminder of how you find X-intercepts. Okay, so for any graph, you can find the x-intercepts by setting y equal to 0 and solving for x. Okay, now with a quadratic, we know that when we solve for x, we'll have two solutions. Okay. Right, each x-intercept comes from one of those solutions. So we know that we're normally going to have two x-intercepts. Okay, and to start, we're going to try factoring to solve first. Okay. There are other things that you can do to solve for y, or for x, sorry, but we're going to start by trying to solve by factoring. Okay, so let's look at our plan for graphing. Okay, so the first thing we want to do is find our x-intercepts. Okay, so we're going to use this technique. We're going to set y equal to 0. We're going to try factoring, and then that will usually work, and we will usually get two different intercepts. Okay, then we are going to find h. Okay, of the vertex. Okay, so remember, we've been calling the vertex h comma k. So we're going to find the x part of the vertex. And we're going to do this by saying it's halfway between the x-intercepts. Okay, and then the last thing we're going to do is plug in h to the original equation to find k, the y part. Okay. All right, and then the last thing we're going to do is actually graph. Okay, so we'll take those x-intercepts, we'll take that vertex, and we'll make our graph. Okay, so let's go ahead and look at an example of this. Add in our graph here. Okay. Okay, so just like we said in our plan, the first thing we're going to do is find our x-intercepts, and we're going to do that by letting y equal 0. Okay, so we have 0 equals 2 times x plus 3 times x minus 1. Okay, so I'm going to start by dividing both sides by 2. 0 divided by 2 is still 0. Then this 2 is divided by 2 gives us that 1 in the front. Okay, and now we're going to set each of our factors equal to 0. Okay, so we're getting x equals -3 and x equals 1. Okay, and each of these is going to be an x-intercept. -3, 0, and 1, 0. Okay, and I'm going to go ahead and plot those on the graph. -3, 0, and 1, 0. Okay. Now our second step is to find the x part of the vertex. Okay. So it should be halfway in between. Now I like to do this visually, where I go in 1, here I'm going in 1, then here I go 2, and there I go 2, and I can see visually that the middle is going to be x equals -1. Okay. Now, if you are not happy with that, you don't like the visual method, or if you're not sure using that method if it's exactly halfway or not, you can always add these x values together and divide them by 2 to find the halfway point, right? So you could always do -3 plus 1, right? Just adding my two x values together and divide by 2, okay? So this would be -2 divided by 2, or -1. Okay, so that gives us the exact same result. Okay, so h, the x part of my vertex, is -1. Okay, and then I'm going to plug in that -1 to find k. Okay, now that I have the x part of my vertex, I want to find the y part of my vertex. Okay, so I'm going to take my original equation, y equals 2 times x plus 3 times x minus 1, and I'm going to plug in -1. Okay. Alright, so this is going to give me 2 times 2 times -2. Okay, so this is going to be -8. Okay, so this tells me that my vertex is the point -1, -8. Okay, so I'm going to go to -1, -8. Okay, and draw my vertex, and then I'm going to connect these with the best parabola I can. Okay. Okay, so we're still using 3 points to graph, just like the previous method, but instead of using the vertex and the 2 key points, we're using the vertex and the 2 x-intercepts. Okay. Let's do one more example of using this method to graph. Okay, and I want to look at a slightly different example, one that's not already factored for us. in our graph here. Okay, so let's go ahead and look at how to find the graph for this. Okay, so the first thing we're going to do is still find the x-intercept, and we are still going to do that by letting y equal 0. Okay, so I'm going to plug in 0 for y. Okay, and then I'm going to factor. So I'm looking for something that multiplies to negative 10 and adds to positive 3. So I think this should be negative 2 and positive 5. Okay, and then I can set each of my factors equal to 0. And I get two solutions, x equals 2 and x equals negative 5. Okay, and this is going to be the x-intercept 2, 0, and this will be the x-intercept negative 5, 0. Okay, so just like before, I want to point out the correspondence between the x-intercept 2, 0, the solution x equals 2, right, and then the factored form where we have x minus 2. Okay, and it's the same with this correspondence. We have the x-intercept negative 5, 0. That comes from the solution x equals negative 5, and that comes from the factor x plus 5. Okay. Now we're going to go ahead and find h. Okay. So we will use the method where we add them together and divide by 2, just so that you can see that again. But you can always use the geometric method, okay? So if you go out to negative 5, 2, 3, 4, 5, okay, and then out to 2, okay, you will see that the geometric halfway point, right, if you visually determine the halfway point, that will be the same point that we get from adding together and dividing by 2. Okay, so 2 plus negative 5 divided by 2. So this is negative 3 divided by 2, or negative 1.5. Okay? So this is going to be our halfway point. And like I said, you can see that that visually is halfway between those 2 points. Then I'm going to plug that into the original equation to find my value for k. Okay, so here's my equation. Y equals x squared plus 3x minus 10. Okay, and I'm going to plug in negative 3 halves. Okay, so negative 3 halves squared is negative 3 squared, that's 9, over 2 squared, that's 4, okay, plus 9 over 2 minus 10. Okay, so I'm going to give these all a common denominator of 4. So this is going to be plus 18 over 4, and this is going to be minus 40 over 4. Okay, so now I can add my like terms. So 27 minus 40 is negative 13 over 4, okay, which if we want to put that in a decimal so that we know where to graph it, that's an okay thing to do, okay? So this is the same as negative 3.25, okay? So then our vertex, right, is negative 1.5, negative 3.25. Okay, so I'm going to go to negative 1.5, negative 3.25, just here. Okay, and then I'm going to draw the shape of this graph. Okay. We will do lots more examples of graphing in class, so I will see you guys there.